Alright guys, welcome back. Today we're going to be doing chapter 13, chi-squared test. So we have two types of chi-squared tests. We have the goodness of fit test, which we test the frequency distribution of a categorical variable is different from expectations. So here in the goodness of fit test, we would be comparing our observed frequencies and comparing it to the expected frequencies. So you guys might see that in the question where they'll give you the expected. We're going to have to calculate the observed, and then you compare it after, and I'll show you guys later. So test of independence, well, we want to test if two categorical variables are related to each other. So here on the right, I'm just going to show you what a chi-square test, and it's usually, as you guys can see here, for degrees of freedom 2, it's more skewed to the right. As you guys can see, let me highlight that for you guys. It's skewed to the right. The higher you put your degrees of freedom, the more it looks like a normal distribution. So you guys can see it's still skewed to the right, but it's looking more and more like a normal distribution. So degrees of freedom 6, you could see it's still, let me get my black pen. So the mean would still be here, and it is skewed to the right. So when we use our table, you'll see that it is a right-tailed table. So just for you guys to know that. So let's go to the goodness of fit test. Well, we want to compare the chi-squared value to the critical chi-squared value to reject or accept the null hypothesis. So let me highlight that for you guys. So the chi-squared value is something that we have to calculate using a formula, and the critical chi-squared value is one we will find in a table. So just for you guys to know, because I'll be using the critical and calculated chi-squared value throughout the video. So just so you guys don't get confused. So the first step to do is to calculate the expected frequencies. So with the formula, let me highlight that, of n times pi, we get the expected frequencies. So n is the total sample size and p is the probability of a category. So goodness of fit test, as you guys can see on the top, it's we want to compare the expected to the observed. So we'll have different categories in of sorts. So that is, you just want to get the probability of one category, not of everything. And so you want to find the calculated chi-square. So using the formula of x squared, which is our chi-square, it's the sum of the observed minus the expected to the square root, not to the square root, to the power of 2 divided by our expected. So looking back at the formula on top over here, you want to do this, or you want to do, I should do this in fact. So for all categories, and that's going to give us, so if you do that for all categories, that's going to give you your expected frequencies for all of them, and that's why, here, let me highlight it for you guys. That's why we want the sum. So guys, don't get confused if you're doing step 1 more than one time, because you want to find the expected frequencies for all your categories, and then you want to sum it up. You want to sum up all your categories using the chi-squared test. So using the formula, O, as I said, was the observed frequencies, and E is the expected frequencies. So I believe I made a mistake in the beginning when I said that in a question they might give you the expected and we have to find the observed, but I think I reversed that. So typically it would give you the observed and you would have to calculate the expected. So as you guys can see, that since we're calculating up here the expected, they're going to give us the observed usually in a question. So hopefully I made that more clear and it's not confusing for you guys. So find the critical chi-square value. So critical, again, is the table. So the critical chi-square is given by a chi-square table. So to find your chi-square table and to make it useful, you need to find your degrees of freedom. So it's by the formula of degrees of freedom is equal to k minus 1, where k is equal to the number of groups. B, find the significance level. This is usually given. So if it's not given, if you guys are just given the confidence level, you could use the formula highlighted right now, that 1 minus confidence level. And confidence level would be like, we are 95%, we are 90% confident in this and this, and alpha is just the opposite of that, so it would be 0.1 or 0.05 typically. So now we're going to be using the table. So let's just, let me see if I do any numbers here. So let's just say we have our alpha of 0.05 and our degrees of freedom of 7. Well, as you could see where they meet, let's see here, it'd be 0.067. And so what you could do is now reject or accept the null hypothesis. So if our calculated chi-square, which is, let me go back up, which is this part, which is right here, calculated, if that is greater than our critical, which is what we just found with 14.067, well then we can reject our null hypothesis. So I'm highlighting that right now. And if calculated chi-square is less than our critical chi-square, then we can accept the null hypothesis. So hopefully that helps you guys. So that is our goodness of fit test. So now we're going to be going into the test of independence. So we want to test whether two categorical variables are related, and this is a non-parametric testing. So the first step is to calculate the expected frequencies, and the test of independence and goodness of fit test is pretty much doing the same steps with a little different formulas, a bit of different formulas. As you guys can see that the expected frequency formula is a bit different from the goodness of fit test, but our chi-square formula right here in step 2 is the exact same. So going on to finish off step 1, calculate expected frequencies. What's our row total times the column total divided by the grand total. So like I said in the other step, you're going to be doing this more than once. So let me just put this in green. So more than one time. So in the beginning for me, it was confusing because I would only do row total times column total, but you want to do that for all of them. So let's say, let me try to draw you a table real quick. So if we have, I don't know, let's just come up with some random numbers. So if we have 5, 6, 7, and 8, so this would be 11. This would, let's say, our totals. I won't write anything here, just random things. So this would be 12, 14, 15, and then 26. Okay, so then what we would do is, for the first step of calculating expected frequencies, so the row total would be, so we're going to do this for the first row. So 11 times 12 divided by our total of 26 plus, and then, so you would do this, expected frequencies, and then you would do another one. So let me just do a comma. We would do, so now we're going to do, so let me just make this more clear. So 11 and 12 was the first step we just did. As you guys can see, 11, 12. So now we're going to do 11 and 14. So 11 times 14 divided by 26. And now we're going to do it with 15. So let me get 15 and 12. So 15 times 12, parentheses, and then divided by 26, and then 15, 15, and 14. So 15 times 14. So you want to do them with all of them. And then, so these are our expected frequencies. So let me just do expected frequencies. And so this would give you like I didn't calculate it, but you guys would calculated it. Okay, so then for the chi-squared, you will be using your E more than once. So for every single E here, so all of these, let me put an arrow. This is one E. This is one E. This is one E. This is one E. So you'll be using these E's for each of their own calculated chi-squared. So once you've done that, you just sum up all of them, and that's going to give you your chi-square. So step 3 is to find the critical chi-square value. So using the chi-square table. So once again, it's the exact same steps. We'll find degrees of freedom, and our degrees of freedom is a different formula from the other one. So here, degrees of freedom is the rows minus 1 times columns minus 1. So yeah, our B is the significance level. Alpha, like I said before, it's just it's not given, it's just 1 minus the confidence level. And then C, use the chi-square table. So yeah, like I explained before, let's say our alpha is 0.05, our degrees of freedom is 7. We just go here, 14.067. So there's nothing different between this table and the other table. It's just the way that we get to the number. So so yeah, it's a test of independence, as you guys can see, is using different formulas. So you'd be getting different numbers if you were to use the same numbers and mistakenly use a goodness of fit test. So that's why it's important to pick the right type of chi-square test. So then again, we want to reject or accept the null hypothesis. Well, if the calculated chi-square is greater than our critical chi-square value, we reject the HO because our variables are unrelated. If the calculated chi-square test is less than the critical, we want to accept our null hypothesis because the variables are related. So, and if p-value is greater than alpha, we want to accept it. Let me just highlight the greater than. And if the p-value is less than or equal to alpha, we must reject. So let me just go into finding the p-value, and the p-value is used to compare it to the alpha. So finding the p-value, well, the p-value is the probability that represents a test statistic extreme or more extreme than observed, assuming the null hypothesis is true. So the p-value ranges between 0 and 1. So let me highlight that, 0 and 1. And we compare p-value to alpha, our significance level. So p-value is greater than alpha. We must accept our HO. So let me write that. Accept HO because it is not significant. And if p-value, as I said before, is less than or equal to alpha, we reject our hypothesis because it is significant. So how to find the p-value with your chi-square test? Well, we first want to find the degrees of freedom. So let's say in this example, our degrees of freedom is 3. We have to find our calculated chi-square. So depending on which test you do, let's say we got our chi-square to be 7.1. So now we look at the table for p-value range. So using 3, or degrees of freedom of 3, we want to look through all of these numbers to see where 7.1 falls in the highest. And as you can see, it's in between these two numbers and it's highlighted in red if you guys can see the difference in colors, 6.251 and 7.815. So we won't find the exact p-value number, but we can find a range of it. So between 6.251 and 7.815 is alpha 0.10 and 0.05. So what we could say is our p-value is greater than 0.1 because it is greater than 6.251, and it is less than 0.05 because our chi-square is less than 7.815. So, and then now we compare our fourth step compared to the alpha. So let's say our alpha in the question is 0.05. Well, our p-value is less than 0.05, so we must reject our hypothesis. So guys, that's pretty much it for our chi-square chapter. If you guys have any questions, leave a comment below. I'll try to answer them and with detailed information, but hopefully you guys understand enough and it's well explained where you guys could do examples. I'll try to upload any examples that I've done and explain what I do. So thank you.